cross. Ooh, purple. I like that. The test cross is a way to try to figure out what the genotype of a particular parent might be. So essentially what we do with the test cross is we take the unknown parents and their genotype, and we cross them with a particular, basically what we call homozygous recessive. Now, if you're doing a single cross, you use the homozygous recessive for that trait. If you're doing a dihybrid cross, you have to do homozygous recessive for all traits. All traits. And the reason for that is because if we do that, we will get very specific ratios of offspring, and we can use those ratios to sort of backtrack and figure out what the other parent must have been. So let's just look at the possible ratios that you could get. Let's take a single monohybrid cross, and let's do something. Let's say there's a gene for dark hair or something. So we'll use a big D for the dominant gene, and we'll use a little d for the recessive gene, or allele, recessive. And so what we have to do is we have to take our unknown parent and cross them with the recessive, homozygous recessive allele. Okay? And so that's what we would do. Now what we're going to do is we're going to pretend that the parent is this and see what happens. So if we do that, the gametes are a big D and a little d from each of the parents. And so we can simply cross that, a big D and a little d. It's an easy cross. All of the babies will end up like this. They all have to have, if we say this was dark hair, right? They would all have dark fur or dark hair. Let's look at the other possible genotype. The other possible parent genotype could be two small d's. So let's pretend that the unknown parent, I'll put the question mark there, is crossed with our homozygous recessive. Well, that's easy to figure out too, right? There's got to be a D here, and a small d here. Those are the only gametes those parents could produce. And so that means that the cross is very simple. The only possible option in this case is a homozygous recessive individual, which would not have dark hair, would have lighter colored hair. So the only way to get a combination of light and dark hair is with the third possible cross, which I'll try to squeeze in here. That would be our unknown parent being heterozygous. And if we did that cross, we would see that this parent could now produce two different gametes. And this parent could only produce one. And so our cross is a little bit bigger. We have this parent, and then here we have this situation. And what we would notice if we did this cross is that there'd be this combination and this combination. Half of the offspring would turn out light-haired, and half would turn out dark-haired. So if we did a test, we would know by the children, or the offspring, what that parent was. So let's say we have an unknown parent, and we cross that with a homozygous recessive parent, and the offspring come out, and they're all dark hair. All dark hair. Well, that means it has to be this situation, which means we know that the genotype of the unknown parent must be this. So that would tell us, after that cross, that the parent must have been a double large D, homozygous dominant. Then, if we imagine that we look at the offspring, and instead of being all dark-haired, they are all light-haired, then we know that the parent would have to be, we go back to our three tests, it would have to be this situation over here. The parent would have to be homozygous recessive as well, both the parent and the test crosser individual. the parent is small d. But if we get a mix, and it doesn't have to be exactly 50-50, remember, because those are just probabilities. That's just the chances of every baby. There's a 50% chance of being light or dark. It doesn't mean that exactly half of all the babies will have to be dark or light. So if the offspring are mixed, even if there's one light-haired baby out of 10 even, if they're mixed, so some dark-haired and some light-haired, then that tells us that there must be a combination. The parent must be heterozygous, the unknown parent, for the trait, because that's the third option. It's the only way right here where you can get both options. So we can use the homozygous recessive individual as a tester for unknown individuals. So you'll often see questions where they'll say a test cross was performed with this particular individual. So when you see the word test cross, you know automatically that the testing parent is always homozygous recessive. It might not say that in the question, it'll just say a test cross, but you have to remember that that's what that means. And you can use that to figure out something about the original parent. So like I said, sometimes you're doing kind of detective work where you're trying to figure out something about the parent's genotypes based on the ratios of traits among the offspring. So you can use, or by doing a test cross, you can use that. And that's essentially all a test cross is. Pretty simple and straightforward.